Okay, there we go. All right, so just going to go through starting from the beginning of this Thinking Skills 2022 paper. Question 1. One piece of a puzzle is shown below. Which one of the following shows a view of the piece from above? So the fastest way to approach this question is to actually just look at which separate regions are visible on the block we've been given when you look at it from above and how they're separated from each other. So first of all, clearly at the top level, we have this area that can be seen from above, and it's going to be enclosed, as in there's going to be a line around it because it has the sides and edges going down. And then the second level down from that, we should be able to see this individual cube by itself like this, which is this blue shaded area. And then the next level below that, we actually have this area here that's partially blocked, but you should be able to see that it's going to form a little L shape behind the cube. And then finally, looking down from bird's eye view, the last section we can see is this bit out the front here, which is again another L shape, but in the opposite direction to this top layer here. Now, looking at these 4 sections, which of the answers match these 4 sections? You can see it's going to be B, because the black section will obviously match here. Opposite to the black section is a smaller L shape down the bottom, which is the orange region. And then we have the L shape, which is the pink one here. And then finally the single square, which is the blue. And that's the only answer that matches all 4 sections correctly. So question 1, the answer is B. And by the way, any screenshot requests can come at the end, or you can just go look at the recording later. Question 2. The train journey from Jasper to Salumba stops at 4 other stations along the way. Jennifer boarded the train at Jasper and got off at the second last station. Cavalli station is located between Wadi and Gadapur. The train stops at Wadi before Anja. The train stops at Anja before Gadapur. Which station did Jennifer get off at? So this would be a linear arrangement type of question. We need to see how these stations are arranged. So to do that, drawing a diagram would be the easiest way. We know that we have a train journey from Jasper to Salumba. So we can label the first one J for Jasper and the last one S for Salumba. And we know there's 4 stations in between. Now it says Cavalli station is located between Wadi and Gadapur, but we don't know where Wadi and Gadapur is, so we can't do this yet. We'll get back to this one. The train stops at Wadi before Anja, and then the train stops at Anja before Gadapur. So one thing we can definitely make sure to have is stops at Wadi before Anja and stops at Anja before Gadapur. Now, coming back to this sentence that we left here earlier, Cavalli is between Wadi and Gadapur. Now, we don't know where Cavalli exactly is because we can see Wadi is here, Gadapur is here, but we know that that means Cavalli is somewhere between here. It could be here, you could have K here, or you could have K here. Either works, but it doesn't matter because we know that the question wants what station Jennifer got off at, and she got off at the second last station, which is guaranteed, is guaranteed to be Gadapur here. So it doesn't matter where K goes because the final answer will be the second last station, which is D, Gadapur. Question 3. Taller adults tend to have larger feet. Monaro says, your dad wears size 9 shoes and he's not as tall as my dad. So my dad's shoe size must be at least 10. Kevin says, no, that's not right. My dad's feet might be bigger than your dad's. If the information in the box is true, whose reasoning is correct? So the information in the box says taller adults tend to have larger feet. Note that tend means it's not a guarantee. It's not taller adults definitely have larger feet. Tend is saying usually or typically. Now, looking at the statements then, Monaro says your dad wears size 9 shoes and he's not as tall as my dad, so my dad's shoe size must be at least 10. Now, logically speaking, if taller adults had larger feet, Monaro's statement would be correct. But remember, I just pointed out 10 means usually, so it's not a guarantee. So the issue with Monaro's statement is this must. You can't guarantee this using something that's only a usual circumstance or a tending circumstance. So Monaro's statement is not correct. And then Kevin, no, that's not right. My dad's feet might be bigger than your dad's. This is correct because, again, might is saying there's a chance. So it's not a guarantee, but there's a possibility that it could be. And so Kevin's statement is correct. Therefore, the answer will be B, Kevin only. Now, if there's any questions or anything that you guys are confused about as I'm going through, you can still feel free to let me know in chat and I'll still respond to it along the way. So don't worry too much about that. Question 4. Access to the meeting room for a secret club is only possible by answering 2 security questions. The questions are based on the following sentence. Only members will be allowed in. Each day, everyone is given a number, which is the starting position. When anyone arrives at the door, they are given 2 numbers and have to say the letters that appear in those positions if counting starts at that day's starting position. Today, the first person was given the numbers 4 and 8 and responded with the letters E and O, which was correct. The second person was given the numbers 3 and 10. What letters should be given as the response? So this question appears to have a lot of background information, but the really relevant information is every day we have a starting position that we count using this sentence. Only members will be allowed in. And then when someone gets to the door, they get 2 numbers and they have to say which letters correspond to those 2 numbers when you start counting from wherever the starting position for that day is. Now, the example we were given was one person today was given the numbers 4 and 8 and responded with the letters E and O. We don't know where the starting position is, so we can't actually count where number 4 and number 8 is. But we do know that between the numbers 4 and 8, there's going to be 4, right? 4 letters. 8 minus 4 is 4. So essentially, we're looking for a location in our sentence where E and O are exactly 4 spaces apart or 4 positions apart. And if you have a look, you should be able to see that this is where it will be. E here and O here, they are 4 positions apart. There's no other place in this sentence where that works. Therefore, we will have number 4. Let me make this a bit thinner. Number 4 is this E here, and then number 8 will be this O here. Now we're looking at someone who was given the numbers 3 and 10. So 3 is obviously just the letter before number 4. So that's going to be B. And then 10 will be 2 after 8. So 8, 9, 10. 10 will obviously be this E here. So the 2 letters corresponding to 3 and 10 will be C, B, and E. Question 5. A bird sanctuary has 4 parrots, Cliff, Echo, Muse, and Sky. Staff at the sanctuary are keeping track of the treats the parrots like to eat. They have found that if a parrot eats apples, it also eats carrots. If a parrot eats carrots, it also eats melons. No parrot that eats carrots also eats peas. Based on the above information, which of the following must be true? Now, these sorts of questions are typically easiest to answer using a Venn diagram. Not always necessary. You could do it without a Venn diagram, but it's just a little bit more straightforward to visualize something than just think about it in terms of the words. So starting with, if a parrot eats apples, it also eats carrots. That basically means that for any parrot that eats apples, it has to be within the group of parrots that eat carrots, right? If it's within the apple circle, it has to be in the carrot circle. And then if a parrot eats carrots, it also eats melons. So if it's in the carrot circle, it also has to be in the melons circle. So the melon circle is outside the carrot circle. And then finally, no parrot that eats carrots also eats peas. This means the peas circle is outside the carrot circle. It doesn't touch the carrot circle. Now, we don't know exactly where the peas circle is because you could have peas being overlapping here because this is not touching the carrot circle. The carrot circle is this one over here. Or you could have it completely outside the melons altogether, just a separate circle by itself. That also works because this still doesn't touch the carrot circle. So as long as it doesn't overlap with carrots, the peas circle can be anywhere. So looking at that, which must be true then? So A, if Cliff eats peas, he also eats apples. You can see clearly no, because both of the peas circles are not within the apple circle. There's no overlap. So A is false. B, if Echo does not eat peas, he does not eat carrots. So that's not true. If Echo doesn't eat peas, then he could definitely eat carrots. There's a possibility that he could just be in here. So B is incorrect. C, if Muse eats peas, she does not eat apples. Here we can see for anyone who's within the peas circle, they're guaranteed not to overlap with the apple circle because peas is outside of carrots and apples is completely inside carrots. So C must be true. So question 5, the answer is C. Question 6. The principal of a school says PE classes should include non-competitive sports such as bushwalking and dance, and not just focus on competitive sports like football and tennis. Many students do not enjoy playing against their friends and classmates as it often leads to unhealthy rivalries. Which of these statements, if true, most strengthens the principal's argument? So, first of all, summarizing the principal's argument, the principal says PE classes should include non-competitive sports and not just focus on competitive sports. The reason for this argument is many students do not enjoy playing against their friends and classmates because this creates unhealthy rivalry, so unhealthy competition and bad friendships and bad relationships within the class. Now, strengthening is going to be something that adds to the reasoning of this argument. So A, playing a competitive sport is a great way to learn the importance of teamwork. This is clearly going to be opposing. So it's not strengthening, it's weakening because it's showing the benefits of competitive sport. Whereas the principal is saying we shouldn't just focus on competitive sport, we should focus on non-competitive sport as well. So A is not strengthening. B, non-competitive sports are just as effective as competitive sports at improving fitness. Now you can see B does not add to this particular reason in the passage because the passage's reasoning is about creating unhealthy rivalries. However, B gives a new reason which adds to the same argument. It's a new reason for the same argument, which is also going to be strengthening the argument. So B will be strengthening. And to go through the rest, so CEP classes are compulsory for students to attend. This is not relevant. It's more about what sport should be taught in PE and not whether they're compulsory or not. And D, students like to have a range of different sports that they can choose to play. Now, D, whilst it seems like it kind of strengthens the argument, it's a little bit weaker than B because D focuses on having a range of different sports, but this doesn't talk about competitive or non-competitive. You could have a range of different competitive sports. Likewise, you could have a range of non-competitive sports. So just different sports doesn't really highlight the difference between competitive versus non-competitive, which is the main sort of argument in this passage. So D is weak. It's a weak answer because you can still have a range of competitive sports. So it's not directly saying we have to have non-competitive sports. In this case, B is the best answer. Seven, a street has a line of 5 houses next to each other on one side of the road. The 5 houses all have front doors that are painted a different color. A student looks at the houses from the opposite side of the road. The student labels them according to the color of the front door and records which houses are to the left and which houses are to the right of each house. We have this table here, and then which 2 houses are next to the yellow house. So this question is actually very easy to do if you can interpret the table correctly. So what this table shows is for any particular column, the first grid shows which houses are to the left of this house, and the second grid shows which houses are to the right of this particular house. Now, to do this question, you actually only need to look at one row. Doesn't matter which, you can work with either, but I'm going to pick the top one just to show you an example. Again, it's going to be a linear arrangement question, so we want to draw ourselves a diagram. Now, the key to this is approaching the question or approaching the table in a certain order. Looking at the first grid, it's talking about houses to the left. Now, we know that the house that's most to the left would have no houses to its left, right? So if you have the leftmost house here, let's just call this X, whatever that is, it won't have any other houses to its left because it's the leftmost house. So we can go in order and look at which one has no houses to its left, which clearly will be blue because this grid here is empty, right? So blue has to be the one on the left. And then the next house to its right would only have the blue house on its left, which means the next house would be red because red has only one house to its left. And then go in increasing order, which house has 2 houses to its left? It's yellow. And then which house has 3 houses to its left? It's green. And then finally, pink is obviously going to be on the right. So just like that, you've managed to find the order of the houses, and you only needed to use one part of the table. So then which are the 2 houses next to the yellow house, which is here? Well, clearly you can see it's going to be green and red. So the answer for this is D. Blue, red, yellow, green, pink. Yes, exactly. That's correct. 8. Children at John's school were asked to complete a questionnaire about their sleeping habits to find out if they were getting enough sleep. The survey found that people who read a lot at bedtime slept fewer hours on average per night than people who didn't. John, this shows that reading at night does not help you to get to sleep. Which one of the following sentences shows the mistake John has made? So what is the error in his reasoning? So we can see that the survey has found that people who read a lot at bedtime slept fewer hours than people who didn't. And his conclusion was reading at night does not help you to get to sleep. So it does not help you to fall asleep. Now, having a look at 8, it could be that people are reading more because they are having trouble sleeping. So what A is saying is essentially it's not that reading made these people unable to sleep. It's the fact that they couldn't sleep in the first place that led them to reading so much. So A is pointing out a logical mistake, which is that you cannot establish causation in this situation. Just because you have a group of people who happen to read more at night, and this group of people also happen to sleep not so well, you don't know what's the cause of what. So it's not necessarily true that reading is the reason they can't sleep. Maybe it's because they can't sleep in the first place that they chose to read. So A is pointing out the logical error in the issue of John coming up with a causal link when there is no causal link. So false causal link is the error in John's statement. And then B, it could be that people who don't read as much spend more time playing computer games. Clearly irrelevant. This is not relevant to the point of the passage. C, it could be that some children are not allowed to stay up late reading books. Whether or not they're allowed to stay up late doesn't relate to his statement of whether or not reading helps you go to sleep. So again, irrelevant. And finally, D, it could be that some books are more exciting to read than others. Same as the previous two, also irrelevant. We're not comparing the types of books we're reading. So question 8, the answer is A. Question 9. Each card in a set of 15 cards has one of 3 shapes on it: a triangle, a square, or a circle. Inside the shape, a number from 1 to 9 is written. No 2 cards are identical. The only number that appears in both a square and a circle is 7. Which of the following statements must be true? So here we know we have a set of total 15 cards. We know there's 3 shapes, and we know that they have numbers from 1 to 9, which are 9 different numbers. The only number that appears in both a square and a circle is 7. Now we want to consider what sort of scenarios we could have. Given that we have 9 numbers, we have from 1 to 9, we have 9 numbers in total, right? So 9 possible numbers in total. Now let's suppose we want the maximum number of squares. If we consider how many cards could have squares on them, the maximum is 9. Why? Because we can only put 9 different numbers inside these cards. So if all 9 cards have squares, then max we can put 1 to 9 on them, because there are no identical cards. No 2 cards are identical, so we can't have 2 squares with 3 inside. That's not allowed. So the maximum number of square cards we can have is 9. Now, if we have 9 square cards, then maximum we can only have 1 circle card. Why? Because it says there's only one number that's in both a square and a circle, and that's 7. So maximum we can only have a single circle that has 7, because our square cards cover every number from 1 to 9. In this case then, how many cards are we left with that have to be a triangle? So we have 15 cards in total. Square cards, we can have a maximum of 9. Circle, we can have a maximum of 1. So triangle, we can only have a minimum of 5 cards in order to reach our 15 cards. Because you have 9 and 1 make 10. So you have 5 cards left in your 15 card set. So B, there are at least 5 cards with triangles on them. You can have less squares, you can have less circles, I suppose, but you cannot have any less triangles. Question 10. Hermione and her friends each had 3 shots at a target. Zoe scored 8, Bobby missed 1 and scored 4, and Gabby scored 11. All 4 zones of the target are worth a different whole number of points. The middle zone is worth the most points, and each zone is worth fewer points than the one inside it. So we have Zoe, Bobby, Gabby, and Hermione's targets. What did Hermione score? So we know that all 4 zones of the target are worth a different whole number of points. So the easiest way to do this is to come up with an algebraic expression where you represent the different number of points for each region on the target with a different letter. So in this case, I'm going to say, let's just call it, for the sake of convenience, A, B, C, D. So A is this inner circle here, B is the second layer here, C is this third layer here, D is this fourth layer here. Now for Zoe then, we can see she scored 1A, 1 in the A range, so that's 1A. And then no Bs, she had 1C here and 1D here. And that in total gave her 8 points. And then looking at Bobby, Bobby had 1, 2 in the C range. So Bobby only had 2 C's, which gave him a score of 4. And then Gabby had 1 in the A range and 2 in the B range. So it's going to be A plus 2B, which in total gave her a score of 11. Now, what can we work out with this? First of all, we can see from Bobby's, it's quite clear. If 2C is 4, then we know C is going to be 2. Now, looking at Gabby, we have A and 2B equals 11. Remember that the rule was the middle zone is worth the most points, and each zone is worth fewer points than the one inside it. So the middle one's worth the most, and then it gets increasingly smaller as you go outwards. Now, if C is equal to 2, then that tells us B has to be greater than 2, right? B has to be worth more than C, so B has to be bigger than 2. Now, if B is bigger than 2, we can try, guess, and check to see what numbers work for Gabby. So if B is equal to 3, which is the next one up from 2, then in this case, A would be equal to 5. That works, right? Because 5 plus 6 is 11. Now let's test. What if B happened to be 4? If B was 4, then 2B would be 8, which means A would have to be 3, which clearly doesn't work because then A is worth less than B. So we can see there's only one option that makes Gabby's points work, which has to be this one here. A is 5 and B is 3. And once we've got that, then it's quite easy to work out D as well, because using Zoe's equation, we can get D will be 1. Now, what's Hermione's range? So Hermione had none in A's. She had 1B, 1C, and 1D. So Hermione would be B plus C plus D, which is 3 plus 2 plus 1, which gives us 6. So the answer is A. Question 11. Jake and Robert are brothers. Their parents have told them that they will not be allowed to go to the party tonight if they have not completed their homework. Natalie says Jake is coming to the party, but Robert is not, so Robert can't have completed his homework. Daniel says Jake must have completed his homework. If the information in the box is true, whose reasoning is correct? So, their parents have told them that they will not be allowed to go to the party if they have not completed their homework. So basically saying homework is a prerequisite for the party. It's a condition. You have to tick that box, otherwise you're not allowed to go. So homework is a condition for going to the party. So I'm just going to simplify that to say the party, but you know what I mean. Now, Natalie says Jake is coming to the party, but Robert is not. Robert can't have completed his homework. Now, something being a condition means you have to do it if you want to go somewhere else, but it doesn't mean you have to go in the first place, right? So Robert could have chosen not to go, or Robert could have not gone for some other reason. So homework is a condition, but he could have done his homework and still chosen not to go. That's still logically correct. So Natalie is incorrect in saying Robert can't have completed his homework. Daniel says Jake must have completed his homework. This is true because assuming that Natalie was telling the truth when she says Jake is coming to the party, homework is a condition. So if you're coming, you have to have completed the homework. So Daniel's reasoning is correct. Therefore, the answer is B, Daniel only. Some sets of 3-letter words can be ordered so that no 2 consecutive words have any letters in common. For example, bog, cat, dog, met, sup. Another such set of words is given below, but one word is missing and they are not in the right order. Which one of the following could be the missing word from this set? So we know that these 4 words are in the set, but they're not in order. And we know that the rule we have is no 2 consecutive words have any letters in common. So the first thing we should try to find is what letters are most commonly found in the set of words we are given. And you can see here it should be A. So we have age has an A, can has an A, and pad has an A, which means these 3 words have to be separated. They have to have words in between them. Otherwise, it's not going to be able to work. So let's then put age here. And then pad and can would have to go in the middle. So age, or actually, we can start with can. It doesn't matter which way. There's a lot of different ways you can arrange it. But the way I did it was can, and then chuck age in the middle, and then chuck pad here. And we want to see which words can fit where. Now, cot, we can see overlaps with can. So cot cannot go between can and age because cot has a C that overlaps there. So we would have to put cot in between age and pad there. So then looking at what can fit between can and age, well, you can eliminate sun because there's an N, you can eliminate pat because there's an A, and you can eliminate pet because there's an E, then you only have sud left. So this is one way you can arrange the words. It's not the only way. I'm sure there's other ways. We've got one in chat. Age, cot, pad, sud, can. I don't think that works because you have a double up of D. So the one that you've given me, age, cot, pad, sud, can, you have 2 Ds here. And they're next to each other. So I don't think that arrangement works. This is the arrangement that does work. And I think you can still move it. Oh, no, actually, I don't think you can move it. I think this is the only way it works because the can, age, and the pad have to be separated. So one has to be at the front, one has to be middle, one has to be at the end. The only other way you could do this is reverse. So if you start from pad, cot, age, stud, can, that also works. But it's either this order or in the reverse order. And then 13. In Ocean Town, there are 5 different coins: asses, bayos, cots, duets, and ennets. There are 4 asses in 1 bayo, 2 bayos in 1 cot, 2 cots in 1 duet, and 4 duets in 1 ennet. How many asses are in 1 ennet? This one is quite simple. You just have to sort through all the different letters. So 4 asses in 1 bayo, we can just say 4A equals 1B. 2 bayos in 1 cot, so 2B equals 1C. 2 cots in 1 duet, so 2C equals D. And finally, 4 duets in 1 ennet, so 4D equals E. Now, how many asses are in 1 ennet? We can just unravel this layer by layer, kind of like an onion. So 1E is equal to 4D, which is equal to 8C, because 2 C's are 1D, which is equal to 16B, because 2 B's are 1C, which is equal to 64A, because 16 times 4 is 64. So this one's just C. "14. Ying thinks we should all buy soybean oil instead of palm oil for cooking. I found out that growing palm oil trees requires vast areas of rainforests to be cut down," Ying says. "To help save the rainforests and the animals that live in them, we must stop buying palm oil." Which one of these statements, if true, most weakens Ying's argument? So attacking her reasoning. Her argument is obviously we should all buy soybean instead of palm oil for cooking. And the reason is growing palm oil requires vast areas of rainforest, and we want to save rainforests and animals that live in them. A. Palm oil is also used in bath products such as shampoo. This is not relevant because the fact that palm oil is used in other places doesn't mean we can't still reduce our usage by using a different oil for cooking. So it doesn't affect Ying's argument at all. B, people are using less oil in cooking than they used to. Again, even if you're using less, you're still using it. So you could still reduce it by not using it. So again, B does not weaken. It's irrelevant. It's not about how much you use, it's about whether you should use it at all. C, growing soybean also involves the destruction of rainforests. Clearly, we can see that's going to attack this reasoning here. Because our reasoning was palm oil trees sort of destroys rainforests. But if growing soybeans has the exact same effect, then there's no reason we should use soybean oil instead of palm oil. There's no difference. It's going to destroy rainforests either way. So C is weakening. And then D, palm oil is more frequently listed in recipes than soybean oil. So D is sort of an indirect attack, because D is saying that we need to use palm oil sometimes because sometimes we can't use soybean. It just doesn't work. However, the issue with D is it doesn't attack Ying's reasoning. So D is what we would call a counter argument. This is an indirect counter argument. It's saying there's another reason why we need to use palm oil. But D is not saying there's anything wrong with Ying's current argument. It's saying, yes, Ying's argument is true, but sometimes we still need to use palm oil. So it's not a strong weakening statement because it's not actually weakening her argument in any way. It's just saying, yes, your argument is right, but there's something else we need to think about. So this makes D more incorrect. This is indirect, so it's a weaker argument. B may be kind of irrelevant, but it still weakens it a little. I don't think B really weakens at all because Ying's argument is about reducing the amount of oil, palm oil we use. So even if you use less oil in cooking, if you get rid of that less amount of oil, you're still making a difference. So Ying's argument is not saying we're making a huge difference. It's just about making a difference. So as long as you're still using oil, then it's still going to make a difference. So I would say B's not even that much weakening, but I can see your point. It does kind of weaken, but it's very, very remote. All right, and then 15. The skills required for rollerblading, roller skating, and ice skating are very similar. Anyone who can rollerblade can also roller skate. Anyone who can rollerblade can also ice skate. Not everyone who can roller skate can rollerblade, and anyone who can ice skate can also rollerblade. Wei says Shane has been ice skating for years. He will have no trouble roller skating. Talia says Hannah is unable to rollerblade. She won't be able to roller skate. If the information in the box is true, whose reasoning is correct? Again, you can see this is going to be a Venn diagram sort of question. But before we draw our diagram, there's an important thing to see here, which is these two statements. Anyone who can rollerblade can also ice skate, and anyone who can ice skate can also rollerblade. Now, this is a statement of equivalence. So basically, you're saying anyone who can do A can do B, and anyone who can do B can do A, means these two are the exact same group of people who can do both. So these two groups are identical, which means when we're drawing our Venn diagram, we actually have one group here, which is rollerblade and ice skate. This group of people is identical. It's the same group of people who can both rollerblade and ice skate. And there's no one else outside of that who can rollerblade but not ice skate, and vice versa. And then outside of this, we have anyone who can rollerblade can also roller skate, which means using our Venn diagram, we know roller skate is going to be outside of the rollerblade circle. And then not everyone who can roller skate can rollerblade, which is true, which means the roller skate circle is bigger. There's people outside in this circle who can't rollerblade. Now, Wayne, Shane has been ice skating for years. He will have no trouble roller skating. You can see anyone in the ice skating circle will be in the roller skating circle. So Wei is correct. Talia, Hannah is unable to rollerblade. She won't be able to roller skate. Clearly not true. You could have someone outside who can't rollerblade, but can roller skate. So Talia's reasoning is incorrect. Therefore, 15 is going to be A. $16. The string of symbols below contains only 4 symbols. These 4 shown, so at $, and at, and hashtag. What is the only one of these 4 symbols that can be added on the right-hand side of the string to ensure that there is no repetition of 3 consecutive symbols anywhere in the string? Now, this might be a little bit hard to understand. If you didn't understand this question, it would be tricky. Basically, what it's saying is we don't want to see any 3 symbols, 3 consecutive symbols forming one group. We don't want to see that being repeated at any point in the string. So we want to add a random symbol to the right-hand side of the string. If we add a random symbol to the right-hand side, it's going to form, let's say we have this box here, it's going to form a 3-way consecutive string here, which starts with an and then has an at, and then has a mystery symbol here. Now, all we have to do is go back through the whole string and check all of the places that start with these 2 symbols, the and the at. So you can see we have one here, we have one here, and we have one here. Now, what are the symbols after these? So this is one set of 3, this is one set of 3, and this is one set of 3. We have one that ends in a hashtag, one that ends in a $, and one that ends in an at. So we can cross off the ones that already exist in the string, and the only option we have left is the and symbol. So that's the only one that hasn't turned up in the string yet. $17. Sarah wants to persuade her cousin Rhiannon to come to the school play. Her only chance of persuading her is if Sarah's brother Sam is playing in the school band. The problem is it's very hard to get accepted into the band since the standard is very high. Even some very talented musicians have been turned away. You need to really impress the music teacher at audition to stand a chance. Sam does not practice hard enough to get to that kind of level. If the above information is correct, which one of the following is not possible? So what situation do we have here? Rhiannon will come only if, or Rhiannon could come only if Sam is playing in the band, because this says her only chance of persuading her. So it's not saying Rhiannon is guaranteed to come. It's saying Rhiannon might come only if Sam is playing in the school band. Now, we also know that getting into the band is hard. It says you need to really impress the teachers at the audition to stand a chance. Again, this is not a guarantee. Yes, you could impress them, but that doesn't mean you will definitely get in. It just means you have a shot at getting in. So A, Sam impresses the music teacher at audition, but is not invited to join the band. Like I just said, that's definitely possible, because impressing the teacher is not a guarantee for getting in. It's just you have a better shot of getting in. So A is possible. B, Sam practices hard, but does not impress the music teacher at audition. That is definitely, again, possible. There's nothing to say that practicing hard will mean you definitely do well. And then C, Sam does not impress the music teacher at audition, but Rhiannon still comes to the show. Here you can see if Sam doesn't impress the music teacher, he has no chance of getting in the band. If Sam is not in the band, then there's no chance Rhiannon will come. So clearly, it's not possible that Sam didn't impress the teacher, but Rhiannon still ended up coming. So C is impossible. And then D, Sam is accepted into the band, but Rhiannon does not come to the show. Again, it's only a chance of getting Rhiannon to come if Sam is in the band. So even if he's in the band, there's still the possibility that Rhiannon doesn't end up coming anyways. So 17 is C. 18. Scrub jays are a species of bird that will bury some of the nuts they collect in order to save some food for later. Scientists studying the species made an interesting discovery. Some scrub jays move nuts they bury if they see other scrub jays watching them bury the nuts the first time. It is only those scrub jays who have previously stolen nuts from other scrub jays that move their nuts. Logan says that means a scrub jay must be able to predict which other scrub jays will steal its nuts. And then Kimberly says if a scrub jay moves a nut it has buried, you can be sure it has had its nuts stolen before. If the information in the box is true, whose reasoning is correct? So, looking at Logan's statement, a scrub jay must be able to predict which other scrub jays will steal its nuts. So that's not, we don't have any information about that, right? It says some scrub jays will move nuts if they see other people watching, other scrub jays watching them, but it's not guaranteed that others watching them will definitely steal nuts, right? They could just be watching. It's not a guarantee. So Logan's statement is incorrect. We can't predict which ones will steal its nuts. And then Kimberly, if a scrub jay moves, you can be sure it has had its nuts stolen before. Now, remember, this second statement says it's only scrub jays who have previously stolen nuts from other scrub jays that move their nuts. That's not the same thing as what Kimberly's saying, because Kimberly is saying a scrub jay that has had its nuts stolen. So one is you've had it stolen from you, and the other is you've stolen from someone else. So they're two different things. These two are not equal, not equivalent, right? You stealing something from someone else versus having something stolen from you is two separate things. So Kimberly's statement is also incorrect. Therefore, 18, the answer will be D, neither Logan nor Kimberly. It sounds like the scrub jays who have stolen other people's nuts don't want their own nuts to be stolen, so that's why it moves the nuts. Exactly. It's basically like you've done something bad before, so you know that there will be people who also do this bad thing, so you are more protective. It's basically like that. Like those scrub jays, they've done something bad, so they know, or they're scared that other people will do the same bad thing to them. So that's why they move it. 19. In a game called Splot, there are tokens that are worth 2 points, 5 points, or 10 points. I have one pile of 2-point tokens, one pile of 5-point tokens, and one pile of 10-point tokens. It's break when I get to finish question 20. Each pile contains the same number of tokens. The combined total of two of the piles of tokens is 96 points. What is the total of the other pile of tokens? Now, this question is a typical question where you can save time in an exam. And I say that because there's two ways you can do this. One, you just work out how many tokens are in each pile, and you just add them and sort through all of the sort of conditions you've been given. And the other is sort of a cheat method using the fact that we can see the answers have some similarities between them. And because it's multi-choice, sometimes there's sort of shortcuts to the answer. Now, we know that we have the combined total of two of the piles being 96 points. And we know our piles are only consisting of 2-point tokens, 5-point tokens, or 10-point tokens. Now, in order to get a total of 96 from two piles, you have to think about what happens when you add a whole bunch of 2s together, what happens when you add a whole bunch of 5s together, and what happens when you add a whole bunch of 10s together. So you should realize that adding any number of 5s and 10s will not get you a number that ends in 6. It doesn't matter how many 5s and 10s you add together, you're never going to get something that ends in 6. Which means that for the two piles who got a 96 total, one of them must be the pile of 2s. So this must be 2 and 5 or 2 and 10. Or 2 and 10. Either way, one of the piles has to be a 2. Now that means the remaining pile has to be either must be, oh, sorry, I'll just write it out. The remaining pile must be 5 or 10. The remaining pile is either 5 if it was 2 or 10 in the first pile, or it's 10 if it was 2 and 5 in the first one. Now, what that tells us is any multiple of 5 or 10. Out of these answers, there's only one option that fits that, which is 40. Because you can never get 32, you can never get 48, you can never get 56 out of any multiples of 5 or 10. So you can straight away get B without having to figure out exactly how many are in each pile. But if you did, you would see that it should be 8. So 8 times 2 is 16, 8 times 5 is 40, and 8 times 10 is 80. If you add the 16 and the 80, that gives you 96, and you have exactly 8 in each pile. But you don't have to work that out. The faster way is just straight away process of elimination. And that's because you can see 40 is the only one that's a multiple of 5 and 10. And then finally, 20, space exploration is a waste of time. When governments spend money on sending people into space, there is less to spend on helping people in need and on improving services for everyone. Scientists say that when they do experiments in space, they learn more about the universe, but their work would be more useful if it made life better here on Earth. Which one of these statements, if true, most weakens the above argument? The argument being space exploration is a waste of time, and the reasoning is it spends money that could be used for improving life on Earth. A, governments worldwide are increasing levels of education spending. A is not weakening, because just because you're spending more money on something else doesn't mean that you can't spend even more money. You know, increasing funding doesn't mean you can't increase it more. So the argument itself still works, because if you reduce space funding, then you can use that to even further increase other sectors on Earth. So A is not weakening. B, work by space scientists on aviation has increased the safety of flying. B is actually saying spending money on space exploration could actually benefit life on Earth. So it's not saying that the money spent on space is not helping them, or taking away benefits on Earth, because actually spending money on things in space could indirectly improve life on Earth as well. So B is attacking the argument, or attacking the reasoning that says spending money in space means we can't improve life on Earth, because actually we could do both at the same time. And then C, the 1969 moon landing cost over $280 billion in today's money. That's actually going to be strengthening. It's saying, well, look how much money we spent on a moon landing, and think of what we could do with that money if we spent it on Earth instead. So it's not weakening. And then D, experiments on plants in space have shown how we could grow them on other planets. Now, D is a little bit irrelevant because it's about other planets, and our focus is on life on Earth. So you could apply that and say other planets includes Earth, but it's not very specific. We want something that specifically relates to Earth only. So D is not as much of a weakening argument. So 20, the answer is B. Now let's take a quick break, come back at 7:40, and then we'll finish the rest of this paper. All right, see you guys in 9 minutes. Moving on to question 21. At the start of the meeting, every member of the movie club gets one vote on the movie to be watched. Everyone must use their vote. The movie that gets the most votes is the one that is watched that evening. This evening, there are 21 people at the meeting, and there are 5 movies to choose from. Kate says the movie that we watch will need to get at least 5 votes. Samira says if a movie gets 11 votes, then we will definitely be watching it. If the information in the box is true, whose reasoning is correct? So the selection of the movie is by picking the one that gets the most votes. We have 21 people and we have 5 movies in total. Now, Kate's argument is whatever we watch has to have at least 5 votes. In the worst case scenario, where every movie has an equal number of votes, considering there's 21 people, the closest you can get is 4 each. And then the last one gets 1 extra vote because you need 21, right? So 4, 4, 4, 4, 4 makes 20, but you need 1 extra vote. So whichever movie that 1 extra vote goes to, that will be the movie that we end up watching with 5 votes. So the movie that we watch will definitely have at least 5 votes. If anything has less than 5 votes, there's no chance of it being the one with the highest number of votes. So Kate's argument is correct. Whereas Samira, if a movie gets 11 votes, then we will definitely be watching it. Say we have one movie with 11 votes, then the next highest number of votes for the next movie would be 10 because there's only a total of 21 people. So 11 votes is guaranteed to be bigger than the maximum for the second movie. So Samira's argument is also correct. Therefore, the answer will be C, both Kate and Samira. (22) A room measuring 3.2 meters by 3 meters is to be tiled with a pattern tile like the one shown below. The tile is square with a side length of 0.25 meters. So this full tile side length, oops, sorry, that's not very straight. This full tile side length is 0.25 meters. Now, the tiles are laid in lines from one edge of the room to the other. The last line of the tiles will need to be cut for it to fit in. Which one of the following tiles shows how the last tile on the floor could look? So we have the room measuring 3.2 by 3 meters. Now we know 3 meters is going to have a whole number of 0.25 meters, right? The tiles have 0.25 side length, and 4 of those make up 1 meter, so 12 of those will make up 3 meters. So there's a whole number of tiles in the 3 meters. The one that needs to be cut will be the 0.2 left, because 3 meters has a whole number of tiles, but the 0.2 extra meters will not be enough to fit a full tile in. Now you can see this tile pattern consists of 5 squares across. It's 0.25 in total, so 0.2 would go up to here. It'd be 1 square away from the edge of the tile. This would be 0.2. So which tile could be the cut piece? It would be exactly where the dotted line is cut, which is B. (23) Lauren wants to join her school's basketball team. To qualify, players must be at least 140 centimeters tall. Miriam says Lauren was 139 centimeters tall last year, but she has now grown to be 141 centimeters tall. So she will definitely be chosen to be part of the team this year. Which one of the following sentences shows the mistake Miriam has made? So the box says to qualify, players must be at least 140 centimeters tall. But qualify just means to be allowed to have a chance. If you qualify for something, it means you have a shot at something. So again, qualify is not a guarantee. Now, Miriam says she's 140 centimeters, Lauren is 141 centimeters tall now, so she will definitely be chosen. Again, we can clearly see that's not correct because qualifying for something doesn't mean you're definitely selected. And the mistake that points that out would be C. Height might not be the only thing used to choose players for the basketball team. So just because she has enough height doesn't guarantee she satisfies all the requirements to join the basketball team. So 23 is C. 24. 3 switches are connected to a set of 4 lights. When a switch is changed, each of the lights that it controls turns on if it was off, or off if it was on originally. Switch 1 controls the red and green lights, switch 2 controls the red, green, and blue lights, and switch 3 controls the blue and yellow lights. If all 3 switches are off, then all 4 lights are off. Which one of the following is true? So A says it is not possible to have all 4 lights on. However, looking at our switches, switch 1 controls red and green, switch 3 controls blue and yellow, and we only have 4 lights, which are red, green, blue, yellow. So A is possible. If we use switch 1 and switch 3, that will give us all 4 lights on. B, the blue light cannot be on when the yellow light is on. Again, not true. If we only turn on switch 3, that's going to be blue and yellow, so both of them will be on. C, the green light cannot be on when the blue light is on. Again, if we just use switch 2, then both green and blue will be on at the same time, so C is not true. And we're only left with D, the red light cannot be on when the green light is off. And why, you can see every time you control the red light, you also control the green light. So if you turn them on at the same time. If you turn them off at the same time. You can never have one on without the other. But you don't even need to think that clearly through, because you can eliminate the other 3 and you're just left with D. "25. I have just 4 cards. The cards have a letter printed on each side. The cards can be set out to make the following words, and no letter appears twice on the cards. Which one of the following words could be made using the cards?" So we know that no letter appears twice. So the first thing we want to figure out is what letters are actually on these cards. And to do that, we just need to cross off all the double ups. So COAT, coat, we'll leave them all there. Lack, we can leave the L, but the A is a double up, we can get rid of that. The C is a double up, we can get rid of that. We can keep the K, we can keep the B in boat. OAT, all double ups. And then OCK are all double ups. So the 8 letters we have are COATLKBS. Now, which one's on the back of which? Right, we have cards printed on each side, or letters printed on each side of the card. So we only have 4 cards. So in order to make any of these words, we have to use all 4 cards at the same time, which means you can never have 2 letters that appear in the same word being printed on the same card. So for example, C and O cannot be on opposite sides of the same card, because then you can't make the word coat, because you can't split a card in half. So then we can work out which letters are matched with which just by seeing which ones are not in the same word, basically. So C, you can see one option that C is not paired with is going to be B, or this is the only option really, because C is definitely paired with OAT. It's paired with L and K. It's also paired with S, because there's a C in all of these words. So the only letter that C doesn't share any word with is B. And then similarly for O, it can't be C, can't be A, can't be T, can't be B because there's an O here, can't be S because there's an O here, can't be K because there's an O here. So it has to be L. L is the only one that doesn't share a word with O. And then A, the only one that doesn't share a word with it is S. And then we're left with T and K. So given this pairing, just go through and see which of the words is possible to make. And you should see bats doesn't work because it uses both A and S, and we know these two are a pair. Blot doesn't work because it uses both L and O, and these two are a pair. Cabs doesn't work because it has CB and AS. And then we're only left with cost, which works because we use exactly one letter from each pair. So the answer is D. "26. A school excursion to watch a musical at the theatre is scheduled to take place next month. However, it will be cancelled if fewer than 20 students sign up for it. On top of that, even if 20 students or more sign up, there must be enough teachers to accompany them. The school's policy states that there must be at least one teacher looking after every 10 students on an excursion. Rohan says, as long as 2 teachers are available to accompany the students, the excursion can still go ahead. Megan says, if the excursion is cancelled, it must be because not enough students signed up for it. If the information in the box is true, whose reasoning is correct? So the box tells us that there are two requirements to this excursion being successful. Number one is if there is enough students. So it will be cancelled if less than 20 sign up. It will be cancelled, so it's a definite, which means the first requirement is 20 plus students. And the second requirement is enough teachers, which you can see in the passage here. It says there must be enough teachers to accompany them. So both of these are necessary for the excursion to succeed. Now, Rohan says as long as 2 teachers are available to accompany the students, the excursion can go ahead. That's not true, because what if we don't have enough students signing up in the first place? You might have 2 teachers, but what if you don't have 20 students? So Rohan is incorrect. And Megan, if the excursion is cancelled, it must be because not enough students signed up for it. Again, no, because what if number 2 was the requirement that didn't work? What if we had enough students, but we don't have enough teachers? So both of their reasonings are incorrect. Therefore, the answer is D, neither Rohan nor Megan. '27. 4 students were comparing how much they enjoyed English, history, and maths. Emily liked maths more than history. Only Gemma liked English more than history. Wesley and Rohit both liked maths more than English, and no one liked history the least. What is the maximum number of students who could have liked maths the most? So this one, because it's a maximum, we want to try and arrange everyone so that we have maths at the front and see how many we can get. So Emily liked maths more than history. So in order to tick that, we can just have maths first, history second, and English third. Because no one liked history the least. So we cannot put history last, but this ticks our boxes. And then we have Gemma, who liked English more than history. Now, if we try to put maths first, then English more than history would mean we have this situation. But this is not possible because no one liked history the least. So Gemma cannot have history being the last on her list, which means this is wrong. So Gemma would have to put English and then history and then maths. We cannot put history last, so Gemma would have to have it in this arrangement. And then Wesley both liked maths more than English. In this case, we could put maths here, put English at the end, and put history in the middle. That's still liking maths more than English. It never said it had to be next to English. It just has to be more than English. So Rohit could have the exact same maths, history, English. So what's the maximum number of students who could have liked maths the most? It's going to be Emily, Wesley, and Rohit. And it can't be Gemma because remember, Gemma's one has to be this one, which does not satisfy our requirements for maths being the most liked. So maximum 3. '28. 5 keys are placed on a glass table. The image below shows the view of the table from above. Which one of the following is a view from under the glass table? So if you imagine looking at something from the top versus looking at something from the bottom is basically a mirror image of what you see. It's like a reflection. And it's going to be, in this case, a reflection over an invisible axis like this. So a couple of ways to do this, because we want which one of the following is a possible view, we can start by eliminating the wrong ones. So first of all, you can see in D, this key here is facing leftwards. However, our original key here was facing rightwards. And if we reflect it over this dotted line, it should still be facing the right. So D can be eliminated because this key is facing the wrong way. And then next we can compare A. So A, we have this horizontal key is pointing to the right. Whereas in our original image, it was pointing to the left. And again, if we flip it over the dotted line, it should still point to the left. So A is eliminated based on that. And then finally, comparing B and C, the difference is this key here. Is it pointing to the left or right? Again, originally this key should be pointing to the right. If you flip it over, it should still be pointing to the right. So C should be eliminated because it's pointing to the left. And B is the possible view that we have left. And you can compare the other keys, but by this case, you can just eliminate everything else and just pick B and go with it. "29. When players are dropped from the school football team, it is usually because the coach thinks they have not been playing well enough. Sometimes a player will be dropped for not attending training every week. Kylie says the coach said she's going to drop Katia even though she's been playing well. She can't have been coming to all the weekly training sessions. Fiona says if she came to the sessions and started playing even better, the coach definitely wouldn't drop her. If the information in the box is true, whose reasoning is correct?" When you're looking at a lot of these reasoning questions, whenever you see things like definitely, must, will, certain, anything along those lines, they should trigger some warning bells in your head. You should start ringing warning bells as soon as you see those words, because a lot of things are not guaranteed. For example, this box says it's usually because a coach thinks they're not playing well enough, and sometimes a player will be dropped for not attending training. So none of this is certain. There's no guarantees. There's no certainty in any of this. It's all usually, sometimes, maybe, possibly, will, chance, things like that. And looking at Kylie's argument, it says she can't have been coming to all the weekly training sessions. That's a certainty. And Fiona's argument is also the coach definitely wouldn't drop her, which is, again, a certainty. So you can see both of their logic is wrong because they're both certain. Both of their logics is saying this is guaranteed or this is a definite thing. But in fact, the information in the box only tells us there's a chance of each of these things happening. So neither of their reasonings will be correct. "30. Solid glass can actually be better described as a slow-moving liquid. The particles in glass can move just like a regular liquid because they are not fixed in an orderly structure. In glass, this movement is so slow that it cannot be detected during a person's lifetime or even over the course of several generations. Medieval window glass, which has survived to the present day, is often found to be thicker at the bottom than at the top. This clearly shows that glass flows. Which one of the statements, if true, most weakens the above argument?" So the argument is that solid glass is actually a slow-moving liquid. And the reason is that we have this example of medieval window glass, which is found to be thicker at the bottom than at the top. So basically saying all the glass has eventually flowed towards the bottom, which is why it's thicker at the bottom than at the top. So it's giving us an example using medieval window glass. Now, A, glass can be melted, and melted glass, like every liquid, flows and obtains the shape of the vessel into which it is poured. Now, this is about melted glass, which is glass in its liquid form, but the passage is about solid glass. So A is going to be irrelevant to the passage. B, the human eye cannot detect tiny differences in the thickness of glass. Again, it's not about what the human eye can detect. It's saying we've already measured, we've found as a fact that these medieval window glasses have a bigger thickness at the bottom than the top. So it's not saying whether or not human eye can detect the difference. It's that we have already established as a fact that we found this difference. So there's no use arguing against facts. It's not relevant to the argument. And then C, modern buildings such as skyscrapers are often constructed from glass. Again, you can see that's not relevant to whether glass flows, so we're really only left with D. Glass objects from ancient Egypt or Greece, which have remained untouched for millennia, are not thicker at the bottom than at the top. Now, D is what we call a counterexample. So it's different to a counter argument, which is just a separate argument by itself. It's a counterexample. It's saying you gave one example that shows this, but we have another example that shows something different. And so that's going to weaken, because a counterexample is saying, well, you've given one example, but I can give an opposite example. So really, that's not saying that your reasoning is correct, because there's another example of this not happening. So 30 will be D. '31. Alice is having some fun typing dates into her calculator. She types them in the format days, months, years, so that, for instance, the date 7th of March 1996 is entered as follows. You have 07031996. When Alice enters the date 12th February 2021, she notices that it reads as the same date when she turns her calculator upside down. Which of the following other dates will also be read as the same date when the calculator is turned upside down? So the example they gave us was 12022021. Now you'll notice a couple of things about this number. First of all, it's a palindrome, which means it's the same read forwards as backwards. And that's a requirement, because when you turn it upside down, it still needs to read the same. So it definitely has to be the same order front and back. But it's also the same order front and back depending on the reflections. What I mean by that is, when you draw yourself a 2, and because you guys have this on an actual paper, so you can actually do this on the paper and it won't be hard at all, draw yourself a 2 and then flip the paper upside down and see what it reads. One common mistake that people make is people think an upside down 2 is equal to a 5. This is not true. A lot of people think, oh, upside down 2 is 5, but that's not true. 5 is a reflection of 2, but it's not an upside down 2. If you draw a 2 and you flip your page upside down, you'll see it's still a 2. So we actually need to see which numbers correspond to the upside down versions of the other number, not the reflections. So one pair that we can see is 9 and 6. You can have a look here. 9 flipped upside down will be 6. So these two have an upside down flipping relationship. 5 flips into 5, just like 2 flips into 2. Well, just move this over to the side so I have a bit more space. 9 and 6 is a pair. 5 just turns into 5 when you flip it upside down. Same as 2, it still stays a 2 when you flip it upside down. Obviously, 8 stays an 8. 0 stays a 0 because they're just symmetrical. And in this case, we're saying 1 stays a 1. Even though the 1 ends up, oh no, it doesn't even end up on the opposite side. The 1 we just say will stay a 1, even if the 1 gets shifted onto the left instead of the right, but you still read that as a 1, so it doesn't matter. Now, looking at the dates, the first one is 19th of January, 1061. Here you can see from the middle, the 1 and the 1 match, the 0 and the 0 match. The 9 and the 6 we just said was like the upside down version of each other, so that's one pair. And then the outermost pair is the 1 and the 1, which again match. So A is already correct, and you don't have to consider the rest of them. For the sake of time, I would not recommend you try the rest of them, but if you were really unsure in an exam, what you could do is just write out the numbers in the block format like this: 1901 and then 1061, and flip it upside down really quickly to check that if you're not sure. But for the most time-saving scenario, I would just go with A and move on. '32. 6 friends are standing in a circle in the playground facing inwards. Grace is standing to the left of Catherine and is opposite Willow. Max is facing Carrie and is standing next to Catherine. Liam is in between Willow and Carrie. They've been playing a game in which they throw a beanbag to one another in a specific pattern. Someone throws the beanbag to the person opposite. They then hand it to the friend on their left. In the first round, after 3 repetitions of this pattern, Willow is holding the beanbag. Who was holding the beanbag at the start? So before we deal with the throwing and the handing of the beanbag, we first need to figure out what the circle looks like. So we have 6 friends in a circle, like this. Now, Grace is standing to the left of Catherine and is opposite Willow. So suppose Catherine is here. Doesn't actually matter because it's a circle anyways. Then the left of Catherine is here, and that's Grace. And Grace is opposite Willow, so Willow is here. Now it says Max is facing Carrie and is standing next to Catherine. So there's only one spot left next to Catherine, so Max has to be here. And he's facing Carrie, so Carrie has to be there. And so Liam, who's between Willow and Carrie, has to be there. Now, after 3 rounds of throwing to the opposite and then passing to the person on the left, Willow is holding the beanbag. So what you can actually do is work backwards to find who was holding it from the start. So for someone to hand it to the person on their left, and that person being Willow, Willow must have gotten it from Liam because Willow's on the left of Liam. So the second last step before giving it to Willow must have been Liam. And then who gave it to Liam? It must have been the person opposite who threw it to him. So then it came from Carrie. Oh, sorry, not Carrie, Catherine. Now, who gave it to Catherine? Someone passed it to their left, which was Catherine. So that had to be from Max. And then who gave it to Max? The person opposite threw it to him. So that's going to be Carrie. And then who gave it to Carrie? The person who's got Carrie on their left, which is Grace. And then finally, who gave it to Grace? Well, it must have been Willow who actually gave it to Grace in the first place because Willow's opposite Grace. So in fact, Willow was holding it at the start. And after 3 rounds, it ended up being Willow holding it again. "33. Matt and Yash play chess together every day at lunch. They are at around the same skill level and they have each won around half of the matches they've played against each other. Mr. Steed says, I can't remember how many games Matt and Yash played last week, but I know Matt won 5, so they must have played about 10 games. Which one of the following sentences shows the mistake Mr. Steed has made?" So the box tells us that they have around the same level of skill and they've each won around half of the matches they've played against each other. But that is referring to the total number of matches they've played. Whereas Mr. Steed here is referring to only last week. He's saying, well, Matt won 5, so the total must be double that, which is 10. But this is only last week. We're not talking about a specific week. The box says it's the total number of matches they've played over who knows how long, where they've each won around half. So according to that, which answer points out the mistake that Mr. Steed made? It's got to be A. Either Matt or Yash might have played unusually well last week. So last week is not a reflection of their total score against each other. Maybe last week it was a little bit more mismatched, but on the total scale, it's still matched up. So A is going to be the mistake here. "34. Jody and Todd frequently message each other in code. They always use the same code in which each letter of the alphabet is always represented by a unique symbol. For example, Jody is this, so we can write Jody underneath, Jody, and Todd is this, Todd. When Todd asked Jody to name her favorite season of the year, she replied with this. Now, looking at this code here, the first thing we know is that there are no known letters. because none of these symbols appear in Jody or Todd. The second thing we know is there are no repeats, right? There's all different symbols, and we know that each letter of the alphabet is represented by a unique symbol. So if all of the symbols are different, then all of the letters must be different. So what can we eliminate? Summer, because there are 2 M's and there's no repeats. Autumn, because there's 2 U's and there are no repeats. Winter, because there's a T, which is a known letter, which is not in there. So the only option is a spring. "35. The code to open a door in a computer game is a sequence of 4 pictures in a row. You have found the following clues about the code. The bell is next to the book. The apple is somewhere between the bell and the cat, and the book is somewhere to the right of the cat. You have to choose one of 4 possible questions to ask. When the question has been answered, you must deduce the code. Which one of the following questions would allow you to deduce the code?" So we want to see what options we currently have right now. The bell is next to the book, and the apple is somewhere between the bell and the cat, and the book is somewhere to the right of the cat. So first thing we know is we can put cat here, and we know the book is somewhere to its right. We know the apple is somewhere between the bell and the cat. So apple will have to go there. We'll just use APP for short. And then bell can go there, because then we have bell next to book, that's ticked. Apple between bell and cat, ticked. Book to the right of cat, ticked. What's another option we have? We can also have cat here, apple here, book here, and bell here. Because again, bell next to book, yes. Apple between the bell and the cat, yes. And then book to the right of the cat, yes. And if you have a think, there should not be any other options that you are able to come up with that satisfy all of these given requirements. Therefore, the only difference is the positioning of these 2. And which question can tell this apart? It's going to be A, is the apple next to the book? "36. Although many although many birds are fiercely territorial, they are typically very sensitive when nesting. If they feel their nest has been disturbed, they often abandon it altogether, even if the female has already laid her eggs. Lorenzo says, my dad accidentally disturbed a nest when he was cleaning the roof, so there's a good chance it may now be abandoned. Katerina says, there's an abandoned nest in the pomegranate tree in our garden. That must have been disturbed too. If the information in the box is true, whose reasoning is correct? So here we have this condition where birds often abandon nests if they feel it has been disturbed. Again, this is a chance. It's a higher chance, it's a likely chance, but it's still a chance. It's not a guarantee. So Lorenzo saying, my dad disturbed a nest, so there's a good chance it may now be abandoned, is logically correct. There is a good chance, but it's still a chance. But Katerina says there's an abandoned nest that must have been disturbed too. Now, if it's disturbed, it might cause them to abandon it. But that doesn't mean there's no other reasons it might be abandoned. So even if it wasn't disturbed, there could still be reasons why they would abandon it. We don't know, and the box doesn't give us any information on that. So Katerina cannot make this conclusion. It's not a must. If they find an abandoned nest, it might have been disturbed, but it could have been other things either. It's not a guarantee. So whose logic has to be correct? It's Lorenzo only. Like I said, with these questions, anywhere you see like a must, a certain, a guarantee, a definite, warning bell triggered in your head. 37. There are 6 coins in a collection where there are 3 large coins and 3 small coins. For each size of coin, there is 1 coin with a circular hole in the middle, 1 with a square hole, and 1 with a star-shaped hole. Each coin is kept in a box. All of the boxes are the same size. Each box has 2 symbols drawn on it. One of the symbols identifies the size of the coin and the other determines the type of hole in the coin, but they may be in either order. The box for the larger coin with the circular hole has the symbols ohms, I think is the symbol. I'm not actually sure what Greek letter that's read as. So we'll just say it's like this upside down horseshoe shaped thing, and then an E on it. The box for the small coin with a square hole has the symbols like a little house and a little triangle delta on it. And the third box has the symbols of a diamond and the house. Which coin could be placed in the third box? So 2 things we know. Large and circular hole corresponds to either one of these symbols. And small with a square hole corresponds to these 2 symbols, even though we don't know which one is which. Now, the third box has the diamond, which is a new symbol that we haven't seen on any of these 2 boxes, but it's also got a little house thing, which we remember is found here. So this third box's coin has 1 overlapping feature with box 2. So this is box 1, this is box 2. The third box has 1 overlapping feature with box 2, which means our coin is either going to have a square hole or it's going to be a small coin. We also know that it has no overlapping feature with box 1. No overlap with 1, which means it's not large and it's also not circular. So then we can cross off. It's not large, not circular. Therefore, we're left with only D. And here you can see the 1 overlapping feature with number 2 would be the fact that it's also a small coin. But ideally, you don't even need to consider the overlap because you can straight away eliminate. There's no overlapping symbols with box 1, so it can't be large and it also can't have a circular hole. So we can cross off A, B, and C altogether. "38. In an athletics competition, there are 4 heats, and every participant runs in 2 of the heats. The finalists are all of the participants who finished in the top 2 in at least one of the heats. Chloe says Tim was faster than Leon in the first heat, so if Leon qualifies for the final, so will Tim. Which one of the following sentences shows the mistake Chloe has made? The box clearly tells us we have 4 heats. Now, any participant who finishes in the top 2 for at least one of them, so in any one of the 4, if you finish in top 2, you can get in. So we only know, according to Chloe, that Tim was faster than Leon in the first heat, but that's only one of the 4. So in that case, even though Tim was faster in this heat, it doesn't mean that Leon was fast enough in this heat to qualify in the first place. If Leon was last in the first heat, then Tim being faster than Leon doesn't mean Tim will qualify. Leon, on the other hand, could qualify by participating in a different heat where he came first. So in this case, which answer points out this mistake? It's going to be C. Leon may qualify based on his performance in his other heat. So maybe in this heat he came last, but he came first in a different one, so he qualified from that and not this one. So Tim can't be guaranteed to qualify just because he was faster than him in the first heat. And then 39. P, Q, R, S, and T are friends. They all have either blue eyes or brown eyes. They each enjoy 2 of the following 4 activities: fishing, reading, playing the piano, and drawing. P likes reading and fishing, Q likes playing the piano and fishing, S likes drawing, everyone likes fishing except one person with blue eyes, and everyone with brown eyes likes reading. Which one of the following statements must be true? So we know that they each enjoy 2 of the list of activities. P likes reading and fishing. Q likes playing the piano and fishing. This tells us everyone, first of all, likes fishing except one person with blue eyes, and everyone with brown eyes likes reading. So we want to figure out what colored eyes people are allowed to have. So one person who doesn't like fishing has blue eyes. So there's only one person who doesn't like fishing, and that person has blue eyes. Now, we know that obviously it can't be Q. Sorry, my bad, take that back. Everyone with brown eyes likes reading. Now, Q does not like reading, which means Q cannot have brown eyes. So first thing we know is Q is guaranteed to be not brown, which means it has to be blue because it's only blue eyes or brown eyes. Then we want to consider S because S likes drawing. Now, S can either have blue or brown eyes, but we want to test what happens if it's either. So suppose S is brown eyes. So suppose S has brown eyes. We then know, in this case, that S likes drawing. But we also know that everyone likes fishing, except one person with blue eyes. So if S has brown eyes, then S can't be that one person with blue eyes who doesn't like fishing, which means S likes fishing plus drawing. So drawing is already a guaranteed. We know S likes drawing. But if S has brown eyes, then S has to also like fishing because S is not that one exception. However, we also know that everyone with brown eyes likes reading. So if S has brown eyes, then this also means S likes reading. But we have a problem because now S likes fishing, S likes drawing, and S likes reading. And this is 3 hobbies and not 2. We've been told they each enjoy exactly 2 of the 4 activities. So this is too many. Now, this is what we sort of call like a contradiction. We say, let's suppose S has brown eyes, but we run into a problem that we can't solve, which means S cannot have brown eyes, which means the opposite must be true. S must have blue eyes. So this is going by a contradiction. We're saying if S has brown eyes, we run into a problem and this question breaks. So S cannot have brown eyes, which means S has blue eyes, which means it's guaranteed that Q and S has blue eyes. So this one is a little bit more tricky because it needs you to sort of imagine what happens if it was one scenario and then see that there's a problem. I would say this one is one of the more trickier questions in this paper. And then finally, 40. When the children in Freetown arrived for class yesterday, the teacher saw that 15 were wearing beanies, 8 were wearing scarves, and 12 were wearing gloves. On closer inspection, he could see that all of the children wearing scarves were also wearing gloves, and that half of the children with a scarf also had a beanie. There were 4 children wearing a beanie who also had gloves but no scarf. There were 2 children with no beanie, no scarf, and no gloves. How many children arrived for class yesterday? Now here, this question, I think the easiest way to solve it is by drawing a Venn diagram and filling out the parts of the Venn diagram. Now, how we draw it is we need to consider we have this overlap of uniform. We have beanies, scarves, and gloves. And so you want to draw yourself a three-way Venn diagram like this. Beanies, scarves, and gloves. Now, how do we fill this in? So first of all, we know that there were 2 children with no beanie, no scarf, and no gloves. So these people are going to be outside this Venn diagram. We can draw them outside like this. We need to make sure that we take into account these 2 people. Next, we know that there were 4 children wearing a beanie who also had gloves but no scarf. So this is going to be referring to the overlap between beanie and gloves that's not in scarf, which has to be this section here. So this section here is going to be beanie and gloves but no scarf using our Venn diagram. And then we know that here, all of the children wearing scarves were also wearing gloves. This tells us that there are no children who wore scarves alone, right? Everyone wearing scarves also wore gloves, which means there were no children, 0 children in this scarf only section. Now, we also know that there are no children in this section because, again, you can't have anyone being in scarves without also being in gloves. That's what this rule tells us. Finally, we know that half the children with a scarf also had a beanie and that 8 were wearing scarves in total. So this means that wearing scarves in total, since we already know that this is 0 and this is 0, the only way we can fit the 8 people wearing scarves means this section must be equal to 8 in total. Now, out of this section, half of them also have a beanie. So out of this 8, 4 of them are in this overlapping region in the middle, which also belongs in beanie. And then the other 4 are just going to be in the normal scarves and gloves section. Now we filled out this, we can fill out the rest of the diagram because we know that there were 12 wearing gloves in total. You can see 4, 4, and 4 already make up 12, so this must be 0. And then beanies, we know there were 15 in total. We've got 0, 4, and 4 so far. That's 8 altogether. So to make up 15 in total, there has to be another 7 wearing beanies only. So how many children in total do we have? We have 7 plus 4 plus 4 plus 4. Plus, don't forget, the 2 outside. So adding all of that together gives us D21. This one is also a little bit tricky. I think 39 and 40 are the trickier ones in this paper, and they need a little bit of wrapping your head around and processing the information. And we have finished exactly on time. So 8:30 exact. Depending on how many screenshot requests you have, I reckon I'm probably just going to send you guys to the recording instead because I went through this quite quickly. So I anticipate there were probably a lot of questions that you missed out on getting screenshots of. So like I said at the beginning, this recording will be published. So you can just go look back through that for any questions that you want to double check over, if that's all right. So I'm just going to end the recording there.